All right, a direct variation takes the equation y equals kx, where this k is known as our constant of variation. And we're going to do two things with direct variations. We're going to graph them as well as set up scenarios that involve when quantities directly or vary directly with others. So when it comes to graphing, the first thing we're going to have to do is write the slope as a ratio of the rise over the run. We should have just had some practice with this in class. And then after that, we're going to graph the origin. All direct variations pass through the origin. Then, once we are at the origin, from that point, we're going to move our rise, so either up or down, and our run, either right or left, and plot the point that's there. And then we connect the dots. So for example, we see y equals 6x. Our slope as a ratio is going to be 6 to 1. So when it comes to graphing this, when we pull out our graph, first we wrote the slope as a ratio, 6 to 1. Then we graph the origin right there at 0, 0. Now we're going to move our rise and our run. So we're going to move our rise is up 6. 1, 2, 3, 4, 5, 6. Our run is 1. We go there. We plot that point. Step 2, connect the dots with a nice big graph that we then label as y equals 6x. So there's that one. Let's look at this. Y equals negative 3/4. The slope as a ratio is already negative 3 to 4. So I'm going to plot the origin, and I'm going to move negative 3 as my rise. So I'm going to fall 1, 2, 3, 4. Or 1, 2, 3, sorry, and run 4. 1, 2, 3, 4. There's that point. I'm going to connect the dots with a nice big line and label this as y equals negative 3/4 x. So there's graphing direct variations. Now, the other thing that we're going to do with direct variations is solve equations with them. So suppose y varies directly as x. I'm going to think a direct variation. And y equals 72 when x equals 8. So we're going to write a direct variation equation relating x and y. So if I'm thinking of direct variation, I'm thinking y equals kx. Now, we know that y equals 72 when x equals 8. So I can plug in this y and this x for y and kx. So now 72 equals k8. I need to find what k is, so I'm going to divide both sides by 8 and see that k equals 9. So now I know my direct variation equation is y equals 9x. So now, part B, I'm going to use that equation to find x when y equals 63. So I'm going to start with my y equals 9x. If I know y equals 63 equals 9x, I'm going to solve for x, so divide both sides by 9, and I'm going to see that then x equals 7. So when y equals 63, x equals 7. Now, suppose y varies directly as x, and y equals 98 when x equals 14. Write a direct variation equation relating x and y, and then find y when x equals negative 4. So again, direct variation, y equals kx. Now we know that y equals 98 when x is 14. And put a little set of parentheses up there so we don't get confused. Divide both sides by 14. And I'm going to see that k equals 98 divided by 14. Trusty calculator. Fun fact, boring fact, I'm not a super whiz with all this computation in my head, and I know that then k equals 7. I rely on calculators, or the old-fashioned way. It's fine. It's nothing to be ashamed of. So k equals 7. So y then equals 7x. Now we need to find y when x equals -4. So I'm going to take y equals 7 times -4. I guarantee you, though, I do know my 0 through 12s. My 0s through 12s, I got those. But 14s, I don't know. So then y equals -28. So when x equals -4, y equals -28. All right? So our practice problems, we're going to look on page 490. 16 through 32 evens, no 28. No 28. So looking at 16, graph for 16, use your graphs that you're given. Use your graphs. And then also make sure you write your slope as a ratio. So we see y equals 10x. That means our slope as a ratio is 10 to 1. And we'll move and follow the steps. Have fun with direct variations.